When you follow the universe outward far enough to feel comfortable imagining regions we cannot see, an interesting question starts drifting back toward the foreground. If all of this exists, if the solar system is small, if the galaxy is vast, if galaxies form clusters, if clusters form superclusters, and if all of that rests inside a cosmic web that stretches into regions beyond our visibility, then where does Earth fit in terms of size? The question is simple, but answering it requires comparing Earth not only to nearby objects, but also to the entire chain of scales we've been travelling through. The result is a perspective that doesn't diminish Earth, but reshapes how we perceive the meaning of small and large. One way to begin is to return for a moment to something familiar. Earth feels big from the surface. Oceans stretch beyond sight. Continents require hours or days to cross. Mountains rise high enough that climbing them becomes an accomplishment. Yet these impressions come from living at ground level. The size we feel is not the size the universe sees. If you were to move just a small distance above Earth, far below the height of satellites, you would already notice the planet rounding beneath you. The horizon curves, the surface becomes a sphere, and the details that once felt enormous blend into a single surface. At this scale, Earth begins to feel contained, not insignificant but finite in a way that the surface never suggests, and that containment becomes more apparent with each additional step outward. The moment you place Earth next to the Moon's orbit, the scale shifts again. The average distance to the Moon is so large that dozens of Earths could line up between the two bodies with room to spare. Suddenly, the planet that once felt vast fits comfortably inside a region of space that the human mind rarely considers on a daily basis. Expanding this comparison further, the orbit of Earth around the Sun adds another layer. Earth's entire orbital path would look modest compared to the size of the Sun if the distances were scaled proportionally. Even though the Sun appears compact from a distance of 150 million kilometers, its mass and volume dwarf Earth's by enormous factors. You could fit over 1 million Earths inside the Sun. If Earth were the size of a grain of sand, the Sun would be a sphere large enough to fill a room. This comparison often brings the first genuine sense that Earth is small, not because it lacks substance, but because the solar system around it is so much larger. Yet even the Sun, impressive as it is, becomes modest when compared to the solar system's total span. The region influenced by the Sun's gravity extends far beyond the orbits of the planets. Comets in the distant Oort cloud orbit so far away that their paths take thousands or even millions of years to complete. If Earth's orbit were a small circle drawn on a sheet of paper, the Oort cloud would extend far beyond the edges of the page. The solar system's size makes Earth look like a point inside a wide, quiet expanse. When you continue upward in scale and consider the Sun's place within the Milky Way, the comparison grows even more dramatic. The entire solar system fits so comfortably in a tiny part of the galaxy that it becomes almost impossible to represent both accurately on the same diagram. The Milky Way spans about 100,000 light-years across. The solar system is less than a light-year in diameter, if you measure out to the very distant reaches where the Sun's gravitational influence fades. Earth's orbit is just a fraction of that fraction. It becomes a dot within a dot inside a structure so large that human senses cannot relate to it directly. This is not a matter of perspective or exaggeration. The numbers themselves confirm it. If the Milky Way were reduced to the size of a large continent, the solar system would be smaller than a single grain of dust on that continent. Earth would be a particle of that dust. From this vantage point, Earth begins to look truly small, not diminished, not unimportant, but one tiny member of a vast stellar population that fills a galaxy stretching farther than any single lifetime could ever grasp. As the comparisons continue, the sense of scale expands again when galaxies are placed in clusters. The Virgo cluster, containing thousands of galaxies, stretches across millions of light-years. Each galaxy inside it contains billions of stars. Each star may host planets. Earth becomes a small world orbiting a single star in a galaxy that is merely one among thousands in a cluster that itself is only one part of a much larger arrangement. The numbers increase so quickly that they stop feeling like quantities and begin to feel like steps in a scale that grows steadily outward. The step from clusters to superclusters amplifies this effect. The Virgo supercluster contains the local group, which holds the Milky Way, and countless other groups spread across a space hundreds of millions of light-years across. Earth's place in this structure becomes almost invisible, not because Earth holds no interest, but because the scale stretches too far for individual worlds to register when placed against the full span of these structures. Even the Milky Way, impressive on its own, becomes a small feature of a larger region. Continuing outward into the cosmic web, the structures become even larger. Filaments span hundreds of millions of light years. Voids stretch between them with sizes so large that the Milky Way could cross some of them and still appear tiny within their central emptiness. Earth does not diminish further, because it is already smaller than what the scale can effectively represent. Instead, the structures around it grow so vast that Earth's size becomes no more or less significant than a single pixel inside an enormous image. This change in relative scale does not erase the meaning of Earth. It simply places it within a larger context. Moving outward beyond the cosmic web to the scale of the observable universe brings additional perspective. The observable universe spans about 93 billion light-years in diameter. This distance reflects how far light has travelled after billions of years of expansion. Within this sphere lie all the galaxies we can detect, all the clusters, all the filaments, and all the voids. Earth occupies a location near one star in one galaxy, near the edge of one filament inside a structure so large that even the Virgo supercluster occupies only a tiny fraction of it. This perspective often prompts a question. Does Earth become irrelevant when placed against such vast structures? The answer lies in understanding how scale works. Earth is small physically, but size does not dictate relevance. The universe contains objects so large that they overshadow entire galaxies, yet that doesn't give them more inherent meaning than a small planet capable of supporting life. The purpose of these comparisons is not to make Earth seem insignificant, but to clarify that physical scale differs from experiential significance. Earth matters profoundly to the beings who live on it. Its small size simply reflects the fact that the universe has room to contain structures of many different scales. What often surprises people when they consider Earth's size in this context is how quickly the scale shifts from familiar to incomprehensible. The progression from Earth to the solar system feels manageable. The leap from the solar system to the galaxy stretches understanding. The jump from the galaxy to the observable universe often requires a different mode of thinking. At this level, scale becomes something the mind navigates through analogy, rather than direct visualization. Earth becomes part of a structure that grows so far beyond intuitive human experience that describing it accurately requires careful mental steps. Another perspective that helps clarify Earth's relative size is to think of how much the planet influences its surroundings. Earth's gravitational pull affects only nearby objects on a scale of planetary distances. The Sun's gravity dominates the solar system. The Milky Way's gravity shapes the motions of billions of stars. Galaxy clusters influence enormous volumes of space. On this scale, Earth's gravitational influence is extremely localized. It shapes its immediate environment, holds the Moon in orbit, and governs the movement of satellites. But beyond that small region, its influence fades quickly. Yet despite this physical smallness, Earth stands out because of what happens on its surface. It is the one environment we know that hosts life. It contains landscapes, oceans, weather patterns, and ecosystems. It is the only place where consciousness has been observed. These qualities introduce a different dimension that is not measured in kilometers or light years. Earth is small physically but immense in complexity. In terms of structures that hold life, it is not dwarfed by larger objects. Size does not determine intricacy or depth of experience. Another way to think about Earth's size is to place it within the timeline of cosmic evolution. The universe has existed for about 13.8 billion years. Earth formed around 4.5 billion years ago. Life began early in Earth's history and evolved over billions of years. The planet's timeline occupies a substantial portion of the universe's total history. This longevity emphasizes that size alone does not determine a cosmic object's importance. A world can be small and yet host long, complex stories that unfold over enormous stretches of time. Thinking about how Earth compares to everything else also highlights an interesting truth. Much of the universe consists of empty space. When comparing sizes, it becomes clear that Earth is small compared to astronomical distances. But galaxies, clusters, and the cosmic web themselves occupy only a small fraction of the volume of the observable universe. Most of space is empty. Earth is small in a landscape dominated by emptiness. That emptiness doesn't diminish Earth. It simply reinforces that matter occupies only a small portion of the cosmic expanse. Considering Earth in this context does not require imagining anything mystical or unusual. It simply involves scaling familiar objects into larger structures. Earth becomes small compared to the solar system. The solar system becomes small compared to the Milky Way. The Milky Way becomes small compared to the observable universe, and the observable universe becomes only a portion of a possibly larger cosmos. Earth's size is real, but its meaning depends on perspective. Once you become comfortable with this comparison, the idea of small begins to shift. Earth is small physically, but size is only one way of describing something. Earth is large enough to host continents, oceans, life, and the entire history of human civilization. It is large enough to generate weather patterns, to sustain ecosystems, and to maintain a complex atmosphere. It is large enough to act as a home. What matters is not the physical size, but the role it plays within the experiences of those who live on it. Another aspect worth noting is that Earth's smallness makes the universe easier to explore conceptually. The scale grows upward in steps that allow each level to feel distinct. Earth is small. The solar system is larger. The galaxy is larger still. The cosmic web is larger than that. Each step upward introduces new structures without overwhelming the mind all at once. Earth's small size provides a starting point from which the mind can expand outward gradually. This transition from Earth to the cosmos doesn't diminish the planet. It enhances understanding. Earth becomes the reference point for comparisons that stretch outward into ever larger scales. And as we continue to move outward in this mental journey, another question begins forming. If Earth is small compared to everything else, then how does time behave across these scales? After spending so much time moving outward from Earth, through the solar system, across the Milky Way, through clusters, superclusters, voids, and the observable universe, a curious feeling often emerges. The universe seems impossibly large, almost beyond what thought can comfortably hold. Yet at the same time, something about it feels connected in a way that doesn't overwhelm. There is a sense that everything, despite its scale, belongs to the same quiet arrangement. The distances are enormous, but the structures behave in ways that link them together. The universe feels vast, but also strangely unified, as if every part participates in a shared pattern. This sense of connection becomes clearer when you revisit the steps you've taken along the journey. Each scale introduces new sizes, new structures, and new forms of organization, but none of them exist in isolation. Earth orbits the Sun. The solar system orbits the center of the Milky Way. The Milky Way belongs to a group of galaxies. The group belongs to a cluster. The cluster sits in a supercluster, and the supercluster occupies a position in the cosmic web. Even the cosmic web fits into the observable universe, and the observable universe itself sits inside a larger region shaped by the laws of physics. No matter how large the scale becomes, every part remains connected to the others through shared processes. Understanding this connection requires thinking about the forces that shape the universe. Gravity, for example, acts everywhere. It pulls objects together on every scale. Planets orbit stars, stars orbit galaxies, galaxies orbit within clusters, and clusters drift within superclusters. Even the large-scale structure of the cosmic web forms because gravity amplifies tiny variations in density over billions of years. This single force links everything from the fall of an object on Earth to the orbits of galaxies across millions of light years. The scale changes, but the underlying process remains consistent. Light provides another kind of connection. Every star shines across space. Every galaxy emits light that travels through the universe. Light carries information from one region to another. It reveals distances, shapes, motions, and histories. When you look at a star, you're seeing an object that may be dozens or hundreds of light years away, yet its light reaches your eyes effortlessly. When you look at a galaxy through a telescope, you're seeing something millions or billions of light years distant, connected to you only because light has managed to cross that space. The universe feels vast because of the distances involved, but it feels connected because light moves through that space and brings information with it. The cosmic microwave background adds another layer to this connection. It is light that fills all of space, left over from an early moment when the universe became transparent. Every point in the observable universe receives this faint glow. No matter where you look, the background remains. It ties everything together by offering a shared history. Every galaxy, every cluster, and every region of the cosmic web formed within the same expanding environment that once glowed much more brightly. The background light is a reminder that the universe was once far simpler before expanding into the complexity we now observe. The expansion of the universe itself also creates a quiet sense of unity. Space stretches everywhere at once. Galaxies drift apart not because something pushes them individually, but because the fabric of space expands uniformly. This expansion affects every region, no matter how far away. It ties all cosmic structures into one evolving continuum. The universe feels enormous because it continues stretching, but it feels connected because that stretching happens throughout its entirety, not in isolated pockets. Another reason the universe feels both large and unified is that the patterns repeat across scales. On Earth, matter forms into familiar structures: mountains, oceans, continents. In space, matter also gathers into structures, though much larger: stars, planets, nebulae, galaxies. These structures form because the same principles apply everywhere. Gas collapses under gravity. Stars ignite in dense regions. Matter clumps together over time. Galaxies form spiral arms or elliptical shapes depending on their history. Clusters emerge where many galaxies form close to one another. The repetition of these processes across scales creates a sense of continuity. You may be looking at structures millions of light years apart, but they arose from the same kinds of physical rules. Time adds another dimension to this feeling. Everything in the universe evolves according to similar processes of change. Stars are born, live, and die. Galaxies merge, grow, or fade. Clusters gather more galaxies or slowly drift apart. Superclusters shift across space. Even the cosmic web evolves over billions of years as matter streams along filaments. These processes occur slowly, but they create a shared rhythm. Earth's history fits into this rhythm. The planet formed from a cloud of gas and dust around a young star. The star formed from a collapsing region inside a larger gas cloud within a spiral arm of the Milky Way. The galaxy formed from earlier generations of stars. The chain stretches all the way back to the beginnings of cosmic structure. This continuity allows Earth to feel part of the universe, even though Earth is tiny by comparison. The atoms in rocks, oceans, and living beings originated in stars that lived and died long before the sun formed. Elements heavier than helium were created in earlier generations of stars or in supernova explosions and then scattered across space. Those elements became part of later stars and planets. The universe feels vast because the distances and timescales are enormous, but it feels unified because everything shares a common origin in earlier cosmic processes. Another factor contributing to this sense of connection is the structure of space itself. The universe does not contain pockets of unrelated physics. The same laws govern every region we've been able to observe. Gravity behaves the same way in distant galaxies as it does in the solar system. The behavior of atoms remains consistent. Light follows the same patterns. This uniformity creates a sense that the cosmos is not a patchwork, but a continuous whole. Even voids, which at first seem like disconnected gaps, contribute to the universe's unified structure. They are not random holes, but predictable parts of the cosmic web. They form because matter gathers along filaments, leaving behind lower density regions. These voids stretch and expand along with the rest of the universe. Their shapes change gradually as the web evolves. They may feel empty, but they are part of the same large-scale pattern that includes the densest clusters. The emptiness emphasizes the presence of the structures around it, making the cosmic web more distinct. Another way the universe remains connected is through motion. Nothing is truly still. The Earth rotates and orbits the Sun. The Sun moves through the Milky Way. The Milky Way moves through the local group. The local group drifts toward the Virgo cluster. The Virgo supercluster moves within the Laniakea supercluster. All of these motions follow predictable gravitational influences. Even though the distances are vast and the motion appears slow from our perspective, everything participates in a broader cosmic flow. The idea that every object from planets to galaxies drifts through space as part of a larger movement creates a sense of continuity. When thinking about the universe as a whole, it becomes useful to recognize that connection does not require physical proximity. Earth is far from most stars, yet starlight reaches us. The Milky Way is far from other galaxies, yet gravity influences their motions. Clusters are far from one another, yet they align along filaments shaped by early fluctuations. The observable universe is enormous, yet every point within it originated from the same early expansion. These connections do not shrink the universe. They allow its vastness to feel coherent. Another aspect of this coherence comes from how we study the universe. Observations from telescopes reveal distant galaxies that behave similarly to nearby ones. Physics experiments show that fundamental properties remain constant across space. These consistencies give us confidence that the universe functions according to rules that apply everywhere. The cosmos becomes less intimidating when you realize that familiar principles guide even its largest structures. This sense of unity becomes more pronounced when you consider how the universe's history unfolds. The early universe was simpler, with matter distributed more evenly. Over time, small irregularities grew into the structures we now observe. These irregularities became galaxies, clusters, and the cosmic web. Everything we see today evolved from the same starting conditions. This shared origin means that all matter is related through time. Even objects billions of light-years apart share a common beginning. When imagining the universe on a human timescale, it can feel static. Stars appear fixed in the night sky. Galaxies seem unchanging. But on cosmic timescales, everything flows. Stars are born and die. Galaxies collide and merge. Clusters shift. The cosmic web stretches. This motion creates a sense that the universe is not fixed, but living in a quiet, ongoing transformation. Earth participates in this transformation, even if human lifespans are too short to notice these changes directly. The feeling that the universe is both vast and connected also arises from how easily we can represent its larger structures in simplified forms. When astronomers map the positions of galaxies, the patterns become visible. Filaments, clusters, and voids appear across the map. These structures look organized, not chaotic. The universe forms patterns naturally, not through intention, but through the combined effects of gravity, expansion, and time. When viewed this way, the cosmos feels like a continuous environment rather than a collection of disconnected objects. Another reason the universe feels connected is that no region exists in total isolation. Even in voids, background radiation permeates space. Gravitational interactions extend across great distances. Expansion affects all regions uniformly. The universe is not segmented into unrelated domains. It is a single, continuous entity with varying densities and structures. This continuity provides a sense that no matter how far apart two regions lie, they still belong to the same overarching environment. Perhaps the most comforting aspect of this connection is that humans can perceive it at all. From a small planet orbiting an ordinary star, people have mapped galaxies billions of light-years away, measured cosmic expansion, detected the faint glow from the early universe, and traced the structure of the cosmic web. These achievements reveal that the universe's laws allow small beings on a small world to understand patterns on the largest scales. This capability reflects a deeper connection. The mind that observes the universe is made of the same matter shaped by the same processes that formed stars and galaxies. In this way, Earth does not feel separate from the universe, even though it is tiny compared to the structures around it. It feels like a point inside a wider pattern, connected by physics, history, and the flow of time. The universe is vast because distances and scales stretch far beyond everyday experience, but it is comforting because it behaves consistently, evolves coherently, and includes every region within a unified framework. As this sense of unity becomes clearer, another question begins forming in the background. If the universe itself is vast yet connected, what does this suggest about where our journey leads next? After moving so far outward, through scales that stretch from the familiar to the nearly unimaginable, a natural impulse begins to pull the mind inward again. It doesn't erase the vast structures we have passed, or diminish the sense of distance we've grown accustomed to. Instead, it creates a feeling of wanting to see everything again from the viewpoint where it all began. The idea of returning to Earth isn't a reversal of perspective, it's a way of threading all the scales together, understanding how the smallest point in our journey relates to the largest. The return is gentle because nothing in the universe demands urgency. Every part of it moves on timescales that outlast entire civilizations. In that quiet stretch of time, there is room for the mind to drift back toward the little world that started the question of scale in the first place. As soon as you start imagining this inward path, something becomes clear. Earth hasn't grown any smaller or larger during the journey. It hasn't changed in size or shape, simply because you've compared it to galaxies and clusters. The change happens entirely in perception. When your viewpoint expands to include structures larger than anything the senses can grasp directly, Earth appears tiny. Yet when you approach again, down through the layers of scale, the familiar details return. Oceans, continents, atmosphere, and life all re-emerge as features that matter, not because they are large or small, but because they are home. The idea of home becomes easier to appreciate after you've imagined the universe at its largest. Stars and galaxies fill the cosmos, but none of them hold the specific patterns of soil, weather, water, and life that Earth does. The return begins by recognizing that no matter how vast the structures beyond Earth grow, the planet maintains a unique role for those who live on it. Its environment developed over billions of years. Its atmosphere evolved to support complex ecosystems. Its surface contains everything humans have ever experienced, discovered, built, or imagined. The scale of the universe does not erase these facts. It simply places them into a broader context. As you begin to step back toward the Milky Way, Earth becomes a distant point again. Not because it shrinks, but because the surrounding structures overshadow it. The spiral arms, the star clusters, the diffuse glow of star-forming regions, all of these features fill the galactic environment with distances that dwarf the width of the solar system. Yet Earth remains in place, orbiting the Sun at the same steady pace it has kept for billions of years. Its size does not matter to the galaxy, but its role matters to the beings who consider it home. This distinction becomes comforting rather than overwhelming. The universe operates on one set of scales, while life on Earth operates on another. Continuing inward, the galaxy no longer fills the view. The cosmic web fades, first into filamentary structures, then into clusters, and finally into individual galaxies. As each layer recedes, the enormity of the universe doesn't disappear. It simply becomes a background for the smaller scales. This transition mirrors the way human perception works. When standing on a mountain, the horizon feels wide. But when walking through a forest, the horizon narrows and the details become immediate. Neither perspective is wrong. Each reveals something different about the world. The universe behaves the same way. When viewed at its largest, it becomes a network of galaxies. When viewed from Earth, it becomes a sky full of stars. Moving farther inward, past the boundaries of superclusters, the structures grow familiar again. The Milky Way reappears not as one point among many, but as a coherent spiral galaxy. The Sun becomes one of its stars. Earth becomes one of the planets orbiting that star. This sequence of reappearing structures doesn't undo the enormity of what lies beyond. Instead, it reinforces the idea that each scale has its own logic. Earth fits comfortably into the solar system. The solar system fits into the galaxy. The galaxy fits into the cosmic web. Nothing needs to be large or small across every scale to be meaningful within its own framework. As the journey narrows further, the solar system becomes the immediate environment again. The orbits of the planets form a pattern that is both simple and stable. The Sun's gravity shapes everything around it. Earth orbits predictably, keeping a distance that allows liquid water to exist and life to flourish. From this distance, Earth becomes visible as a sphere, blue and white when sunlight reflects from clouds and oceans. This view doesn't diminish the planet's size. It highlights the presence of an environment capable of supporting complexity on a scale that doesn't require comparison to galaxies to be significant. Descending closer still, the atmosphere becomes visible as a thin layer surrounding the planet. This layer is small compared to Earth's radius, yet it contains the air that supports life. The thinness of the atmosphere often surprises people when seen from afar, but thin does not mean fragile. It has persisted for billions of years, shaped by volcanic activity, biological processes, and the sun's radiation. Seeing it from this vantage point highlights how much Earth's environment depends on delicate balances that unfolded over long spans of time. Continuing downward, the planet's surface reappears. Land masses, oceans, deserts, forests, and ice become visible again. These features, invisible from the scale of galaxies, now fill the entire field of view. The familiar shapes of continents return, the patterns of clouds drift across the atmosphere, rivers carve through land, waves form and dissolve, weather patterns shift. These details are infinitely more complex than the structures of clusters or superclusters. They change daily, hourly, minute by minute. This complexity reminds you that size is not a measure of dynamism. Earth may be small compared to the universe, but its surface is alive with continuous movement. As the return continues, the details become even finer. Cities appear, mountains rise, forests spread, the textures of landscapes become visible. These features are small in the global sense, but significant within the scale of daily life. The ground beneath your feet, the air you breathe, the sounds of weather, the changing of seasons. None of these require comparison to cosmic distances to possess meaning. They are part of the immediate experience that defines life on Earth. Thinking about the return in this way reveals something subtle. The universe may be large, but it does not erase the significance of smaller scales. The structures beyond Earth give context, not competition. Earth's place in the universe is not diminished by its size. It is framed by it. The journey outward shows how much space exists beyond what we see each day. The return inward shows how many layers of complexity exist within the world we inhabit. These two perspectives complement each other rather than conflict. Another part of this return involves recognizing that Earth is not isolated from the universe. The planet formed from material produced in earlier generations of stars. The atoms in the ground, the atmosphere, and living beings all originated in processes that unfolded in the galaxy long before Earth existed. This connection tightens the sense that Earth belongs to the universe, even if its size is small compared to the larger structures. The materials that make up Earth come from stars. The energy that drives life comes from the sun. The cycles of tides, seasons, and climate arise from interactions with the moon and the sun. Earth is both small and deeply connected to the larger cosmos. Continuing inward, the personal scale becomes the focus. The details of daily life return. Homes, roads, plants, animals, humans, and all the interactions between them become visible again. None of these features appear from the viewpoint of the cosmic web, yet they are part of the same universe. The scale shifts dramatically, but every object, from a human cell to a galaxy cluster, exists within the same physical reality. This connection is not metaphorical, it is literal. The laws of physics governing galaxies are the same laws that allow molecules to form and life to develop. This transition from cosmic scale to human scale creates a kind of grounding. The vast distances and enormous structures do not overwhelm when placed alongside the immediate details of life. Instead, they offer a broader perspective. Earth feels small when compared to the universe, but the universe feels more understandable when approached from Earth. The two perspectives reinforce each other. The large-scale structure provides context. The small-scale experience provides meaning. As the return continues, something else becomes clear. The reason Earth feels like home is not simply because of size or scale. It is because everything humans know, every memory, every story, every discovery, has taken place on or near this planet. The smallness of Earth in physical terms does not diminish its role in human life. The universe contains enormous structures, but none of them replace the meaning of standing on solid ground, feeling air move across the skin, or watching light change through a day. This recognition does not require ignoring the vastness of the universe. It integrates it. Earth is part of this larger structure, not separate from it. The journey outward reveals the scale of the universe. The journey inward reveals the depth of Earth's complexity. Together they create a balanced understanding of place. Earth is small, but it is not lonely. It fits into a universe filled with patterns that support its existence. It participates in a chain of structures that stretches from the smallest particles to the largest cosmic formations. Reaching the final steps of this inward return, the planet feels familiar again. The sounds of weather, the movement of water, the presence of life in countless forms. These details do not contradict the vastness of the universe, they coexist with it. Earth is one expression of the universe's ability to organize matter into complex patterns. Its size does not limit its significance. Its scale does not define its value. It is one world among many, but for those who live on it, it is the world that makes everything else understandable. And as you settle back into the view of Earth not as a dot among galaxies, but as the immediate environment beneath your feet, the sense of scale gained from the journey remains. The universe stays vast. Earth stays small. But the connection between the two becomes clear in a way that feels steady and grounded, not overwhelming. The return doesn't close the journey. It simply brings the perspective back to the place where questions naturally begin, leaving room for curiosity to continue unfolding in whatever direction the mind chooses next.